Hi, I'm Fabio, and welcome to the 6th course about the Python Introductory Course series by martechpost.com. In this module, we will study how we can build interactive plots using the Altair library. In particular, in order to start to study this Python library, let's take a look at the documentation, the official documentation. So let me move here. Okay. So here we are in the official repository, and we begin taking a look at the main page, the overview page. So what is the Altair library? Here in the title is described as a declarative visualization library in Python. In particular, Altair is a declarative statistical visualization library for Python, based on Vega and Vega Lite. Also, the source is available on GitHub, but we don't care about it. Declarative statistical visualization library are concepts that we have already studied in the previous previous courses. But what is Vega and Vega? What are Vega and Vega Lite? Well, if we click here, we go to the official repository about Vega. Vega is a high-level JavaScript API that allows to create interactive plots. So Altair builds a bridge between Python, which will be the language on which we will type our plots, and the JavaScript of the Vega API based on JavaScript. In fact, the easiest way to build interactive plots is to use JavaScript. But if we are coding with Python, we need a sort of bridge that links Python objects, functions, classes, and so on with objects and functions and so on in JavaScript. In particular, here Vega is a visualization grammar library written in JavaScript, but also with Vega you can describe the visual appearance and the interactive behavior of a visualization in a JSON format and generate web-based views using Canvas or SVG. We don't care about the second thing here about Canvas and SVG, but with Vegas we can generate web-based views. Why? Because in the browser implicitly we are running JavaScript. And also remember that the Jupyter notebooks are able to render the JSON. So we will build graphs using JavaScript and JSON, but coding with Python. Next thing that I want to do in order to introduce you the Altair library is to move to this interesting website, the Fernando Irrazabal blog, who made only one post, but it's quite interesting. And the title of this post is "The reason I am using Altair for most of my visualization in Python." Let's move in, and here there's a brief introduction about the Python charts, the matplotlib library that we already covered in the previous course. But talking about Altair, it says again that Altair is a wrapper for Vega Lite, a JavaScript high-level visualization library. Okay, but The Vega and Vega Lite libraries are APIs that are based in the grammar of graphics. What are grammar of graphics? Well, this concept may sound like an abstract feature, but it's the main difference between Altair and other Python visualization libraries. Altair matches the way we reason about the data. So Altair only needs three main parameters: the marks, which answer to the question, do you want the data represented by plots, lines, bars, circles, and so on? The second parameter are the channels, which answer to the question which variable should be mapped to the x-axis, to the y-axis, to the color of the mark, to the size of the mark, and so on. And finally, the third parameter are the encodings, which answer to the question, is the variable a date, a number, a category, and so on. Based on this, Altair will pick sensible defaults to display your data. The Altair library is extremely powerful because it needs only these three main parameters to specify an entire graph, but also, as pointed out here, Altair will pick sensible defaults to display your data. Because of this, sometimes you can feel uncomfortable with this library because you are not allowed to do something. For example, it is extremely difficult to modify a legend. While in Matplotlib, for example, you can create the legend yourself, even if you don't want a legend related to the chart, which makes no sense, but you can do it with Matplotlib. Just for an example, with Matplotlib you have the complete access to the objects, and with this you can completely customize your graph. With Altair this is not possible because of these three main parameters, which answer to specific questions. And for example, here you don't see the question, how would you like the legend to be displayed? This is not intended using Altair, for example. So here we have marks, channels, and encodings. The first one talks about the way we represent the data. Channels refer to the variables, to the x variable, y variable, and so on. And the encodings finally describe the type of variable we are dealing with. So moving on to the section of the official documentation about the Altair Python library, we move to the basic statistical visualization section. And this section will outline some basic tutorials. The first one is related to the data, the second to encoding and marks. Here you can see that the data basically enters in the channels parameters. So data in Altair in the Altair library is built around the pandas data frame. Okay, that's very good because for generally dealing with tables we will use the pandas data frame. One of the defining characteristics of statistical visualization is that it begins with tidy data frames. Okay, that's not a lot of interesting. For the purposes of the tutorial, we start with importing our pandas and creating a simple data frame here. As you can see here, we have a categorical variable in the A column, and in the B column we have a numerical variable. Okay. Now that we have the data, let's see how we can plot this data. The first thing to do, the first parameter to define are the marks. And the marks must be attached to a chart. So the first thing to do is we create a chart object. The chart object, in fact, is the fundamental object in Altair. And the only argument that the chart object can take is the data frame itself, the pandas data frame. So we have told Altair to create a chart and the data we will use, but we have not yet told the chart to do anything with this data. That's where marks and encoding came. So with this chart object in hand, we can now specify how we would like the data to be visualized. The first question: do you want the data represented by points, lines, bars, or circles? This is done via the mark attribute of the chart object. The most convenient way is to refer to the mark underscore and the type of chart you want to display. So for example, here we can display a scatter plot using mark underscore point. The next thing that we have to specify in a chart object are the encodings here, which play together with the channels parameters. So to visually separate the points, because here the output is only one point, it means nothing, we can map various encoding channels, or channels in general, for short, to columns in the data frame. For example, we could encode the variable A of the data with the X channel. And to do this, we call the encode method. So here we create, maybe I zoom a little bit. Here we create the chart object. We tell Altair that we want a scatter plot, okay, using which variables we use, in the x-axis we want to use the A column of this data frame. Moving on, for example, here we tell that the y-axis should be intended as the B column of the data frame object. As you can see here, the Altair already types the X and Y labels and optimizes the chart. But that's another thing, how Altair can understand that A is a categorical variable and B, for example, is a continuous variable, or again a categorical variable. These are numbers, but maybe the variable is still categorical. That's where the encodings came in mind. Is this the variable a date, a number, a category? which means a categorical variable. In order to do this, let's move a little bit down. Here we have the customization. Okay, maybe here we can see this. We have 5 different encodings. The quantitative encoding, which is its shorthand code is the uppercase Q, which means continuous real value of the quantity. O is a discrete ordered quantity. N is an discrete unordered category. T is a time or a date value, and G is a geographic shape. How can we use the encodings? Well, while specifying the channels, here I can type column and the shorthand code for the variables to describe the type of variable. Here, for example, I want to display the acceleration against the miles per gallon, and filtered by the origin, for example, Europe, Japan, and USA. For example, the acceleration is a quantitative column, a continuous variable. The miles per gallon the same, but the origin instead is an unordered categorical variable, and that's why we type here n, a discrete unordered category. Moving back, Altair allows also to specify in the encode method not only the name of the column, but also to compute some functions using a built-in syntax that relate to the specified column. For example, here, if I want the average as a y-axis, if I want the average, the mean of B with respect to the A values, then I just have to type the average of B. Automatically, Altair will understand that we want to compute an operation referring to the B column of the data frame object. Here, for example, we can see that we are using another type of mark, which are in which we want to represent a bar plot. Moving on, here, for example, to just rotate the graph, the bar plot, we just have to reverse the X and Y columns. And finally, we can see what we were talking before, the fact that Altair is based on the Vega JavaScript high-level library, but Vega and Vega Lite libraries return JSON objects that represent a graph, a chart in this case. In fact, let's read the documentation. Recall that Altair's main purpose is to convert plot specification, the 3 parameters, marks, channels, and encodings, to a JSON string that conforms to the Vega Lite schema. This is introductive here to use the JSON method to inspect the JSON specifications that Altair is exporting and sending to JSON as a JSON to Vega Lite. Remember, in fact, that Vega Lite is a JSON API. Excuse me, a JavaScript API. Here you can see, for example, that you have the configuration, the dataset. For example, here we are importing the data frame, and the data frame is stored here. You can see data, this is the name, and then we have a list of all the pairs A, B. This way of de facto representing a chart, because importing de facto the entire dataset can create some problems, because if we want to create a plot that refers to an extremely big data frame, maybe Altair is not the best library to do so, because the JSON that the Altair library will create will be gigantic. Let's imagine that this data frame with only 2 columns has 10 million rows. This means that the JSON sent to Vegalite will have here 10 million couples. That's why the Altair, by its default, limits the dimension of the data frame. And in order to plot charts using bigger data frames, you have to unlock this limitation. Here we have seen how to display a graph, but these types of graph we are able to create this type of graphs even using Matplotlib. Okay, maybe the syntax is clearer, but that's not a big deal. We still have the limitation about the dimension of the data that we are handling. Where the interactive things came in place? They came talking about bindings, selection, and conditions. These three are the ways Altair allows you to make charts interactive. In fact, let's read the documentation. One of the unique features of Altair, inherent from Vegalite, is a declarative grammar. Okay, we already know this information, of not just visualization, but also interaction. There are 3 core concepts of this grammar: the selection object, the condition function, and the bind property. The section object here captures interaction from the mouse or through other inputs to the effect of the chart. Inputs, for example, can be either events like mouse clicks or drags. The condition function instead takes the selection input, so the result of this object, and changes an element of the chart based on the input. So, for example, if I select a section of the graph the condition function will modify the elements of the chart to display only that selection, for example. Finally, the bind property of a selection enables a two-way binding between the selection and an input element of the chart. Of course, interactive charts can use one or more of these elements to create a rich interactivity between the viewer and the data. Okay, let's look at the example. For example, here we have again the miles per gallon against the horsepower. It's quite similar. Before we were talking about acceleration against the miles per gallon. Here we have the miles per gallon against the horsepower, and this is a scatter plot, and is filtered using the origin variable. This is a standard plot. We are able to do this kind of things even using Matplotlib. To make it interactive, we will create an interval selection using the selection interval function. So first thing to do here, the selection object. Let's define a selection object. In particular, here to make things simpler, Altair allows us to immediately use the selection interval object. We select the interval selection type, and we call this object brush. We can now bind this brush to our chart by setting the selection property. So here we have the graph written as before, and we add a selection brush. Now we are able, as you can see here, to select things in a graph. That's fine. With the double click, the things reset. Okay, the result above is a chart that allows you to click and drag to create a selection region and to move this region once the region is created. For example, here I move and then okay, but nothing happens since now. And here we have only used referred to the selection object. Now let's take a look at the condition function. So making the chart respond. So this selection doesn't actually do anything yet. To use this selection, we need to reference it in some way within the chart. To do so, we will use the condition function to create a conditional color encoding. We will tie the color to the origin column for points in the selection, and to set the color to light gray for points outside the selection. So here we have the selection, but now we have to specify a condition, and we do this here. Before, the color was only origin. Now the color is specified using this function that takes as input the selection itself, the column, which will be used inside the selection for points inside the selection, and the color outside the selection. So here the selection is the entire graph. If I select only these points will be colored according to the origin column. And I can also move the selection. As you can see, with this simple change, the color of the points responds to the selection. Okay, in my opinion, we are done for today, yes, for this documentation. So now let's start coding. Let me show you these two. Okay. Here you can see the repository that I've already created named COVID interactive plots. In here we can find the data, which will be the COVID daily deaths per million people, the COVID monthly deaths per million people, and the cumulative COVID daily deaths per million people. I already created the virtual environment and installed the Altair library as specified in the documentation. Finally, I already opened the Jupyter notebook. Here you can see that I activated the virtual environment, and I also called the command Jupyter Lab. Let me show you then the Jupyter Lab. Just a second. Okay, perfect. In this course, we will complete our analysis of the misalignment between non-COVID reported deaths and those estimated from the past. Now we will use the Altair library in order to create interactive plots. In fact, here, as you can see, I've already imported the Altair library and the pandas library and the pathlib library. Let's run the first cell. Next thing we have to do is to define the path from which we will retrieve the data, and this will be called input path, and will be a path object stored in the data folder. Another thing that we have to do is also to disable the number of max, the limitation for the rows that an Altair chart can accept when importing a data frame. To do so, we call the Altair function from the data transformers package. We call the disable max rows function. Let's call it. In this way, we are able to plot Altair charts using whatever data frame we want. Let's recap the Italian regions we were analyzing. We have Lombardy, Veneto, for example, and so on. The Italian regions are 20. And here I import the first table, which is the cumulative COVID daily deaths. I use the pandas function named readCSV, as we do as usual. Let's recap what is inside this table by typing, for example, the info function. Excuse me, I didn't run this cell. Okay. So we have date, region, deaths, and people. Here we are referring to the daily deaths. In fact, the date, as you can see here, is here, for example, describes a date, and we have the deaths, the people living inside the region during 2020, and also the deaths per million people. Now let's start plotting. The first thing we want to do is to draw, if you remember, the cumulative deaths per million people against the time. We wanted to display then a line plot. So we call line this plot, and will be alt chart. We will refer about cumulative COVID deaths, and the mark will be a mark line. Which columns we will use? We will use, of course, date and deaths per million. So here we have encode, and let's make some space. Let's define the x variable, which will be, of course, the time. So the first thing we will do is describe date and writing this is a date time variable. Second, we will describe the y variable as the deaths per million, which is a quantitative variable. Finally, we want to display the deaths per million against time, but also filtering by region. So the color will be our region, which is an unordered variable. Let's run. And also we want to output the line, of course, to see the results. And here we have the deaths per million against the date, and all the lines here represent the refer to one of these 20 regions, Italian regions. First thing to notice is the fact that here date is useless. We already know that looking at the labels, this is a date. So let's remove date. And also let's replace this y label using a tag and describing the axis using some text. In order to do this, for example, here we have to use the alt x function, which takes the column that we want to use as x-axis, x variable, and then we specify the parameter axis as equal to alt axis, the object alt axis, but with title none. Here we are telling basically to create an x object with that refers to the date column, which is a date time variable, but with this axis standard Altair axis, but without title. We can do something similar with the y-axis, but here we want to modify the axis, not to delete it. Axis, we type alt axis, title will be, let me look at my notes, will be cumulative daily deaths per million people. Cumulative daily per million people. Let's run. As you can see here, we have cumulative daily, daily deaths per million people, and here we have no label. Also, we want to modify the legend, which is defined here using the color parameter. And in a similar way, we type that color is equal to the color object, which refers to this column of the data frame. But first thing to do is that the axis will be alt axis with title equal to region. Excuse me, what's wrong? Oh, sorry. I made a mistake, because color does not define an axis, but it's a legend. So here we have to type legend and define a legend object. Legend. Okay. And here you can see region. This can be fine, but we also want the color to be a little bit more clearer. Also to define an opacity, and we will see why in a minute. And also I want the line to be a little bit bigger. Let's do these things. In order to do to make the lines a little bit bigger, we can define the size property as alt value of 4, for example. You can see that the lines are now bigger. Another thing that I want to do is to define a palette for our legend. And the palette can be defined as scale, using the scale parameter, which refers to the scale object, and we type here scheme is equal, so scheme is the palette, category 20. Fortunately, the regions, we have 20 regions, and the palette is called category 20. In fact, the palette has 20 colors. Okay, this and allows us to distinguish the lines a little bit better. But still, the legend here has lines that are too small, and also we want to increase the dimension of the graph and make and create a title for this chart. and increase the font size of the legend label, the Y label, and so on. So let's do this one thing at a time. First, let's configure the axis, and we can do this by referring to the configure axis function. We type that we want a label font size equal to 12, while the title font size will be 14. Then we want to configure the legend. In the same way we have configured, here we are missing an N. In the same way we have configured the axis. So configure legend, and we type the same. Okay. But also let's run this in order. Okay. Things, the labels are bigger. Still, we want the chart itself to be to have bigger dimensions, but we are unable to identify to correlate the lines to the legend, because the lines in the legend are too small. So we have to increase this aspect, and this is called the symbol. This property is called the symbol stroke width, and we make it equal to 8. As you can see here, this is bigger. But now, since the strokes are bigger, the legend is bigger than the chart itself. That's why we would like to increase the chart dimension, and we can do this by calling the properties generic method. Properties generic method, defining a width of 600 pixels and an height of 400 pixels. Very good. Now we can understand that, for example, this violet line refers to Lombardy. And for example, this green light blue line refers to, let's say, the Valle d'Aosta region, which is this one here, the smallest region in Italy. We are missing just one thing in order to make this chart pretty, and it's the title of the chart. The title of the chart can be specified in the generic properties method. So title will be cumulative COVID-19 daily deaths during 2020. We want also to increase the dimension of the title, because we have modified all these font sizes. In order to do this, we just have to call the configure configure title. Here we call the properties. Configure title what would be simply font size, and will be of 24. Something is missing, a comma here. Very good. We have created a graph in a similar way we have done in the previous course using Matplotlib. Now let's introduce the interactive part. As we have seen in the documentation, we have to define, first of all, a selection. So let's run selection. Selection is a variable that is defined as alt selection multi. This means that we can select multiple filters in the legend. The fields, since fields will be region, and also the bind will be legend. We bind the selection to the legend. We have created the selection. Now we have to introduce the selection. First of all, by adding the selection here. For example, we can add here, add selection, and we type the selection just defined. But as we have seen before, adding a selection does nothing. We want when a region is not selected, we want its line to be almost transparent. We can do this by referring to the opacity parameter defined as alt condition as written in the documentation. We define the selection, we bind the selection, and to make the selection effective, we have to refer to the alt condition function. So the alt condition function refers to selection, takes as arguments selection, the alt value 1. This means that when using this selection, defined selection, the object is selected, then opacity will take value 1. Otherwise, alt value will be 0.2. Let's run. Here we begin, maybe let me zoom out a little bit. Here we begin with a chart with all the regions. Now, if I toggle only one element, one region in my legend, only the line that refers to that region will have opacity equal to 100%. All the others will have opacity 20%. How can I select multiple regions? I have just to press Shift and then the other region. For example, here I select Abruzzo. Valle d'Aosta, Sardinia in English, Puglia, and so on. Double click to go back to the previous setup. Here, for example, you can see that despite the fact that Valle d'Aosta is the smallest region in Italy, the second COVID wave was impressive. The magnitude of the second wave was the biggest one with respect to the other. Of course, because we are considering the cumulative daily deaths per million people. Otherwise, we could not compare, for example, Valle d'Aosta with Lombardia, because Lombardia has 100 times the people that are living in Valle d'Aosta. Okay, now let's move to the COVID-19 daily deaths per million people. So we refer to not the cumulative daily deaths, but the actual daily deaths reported with respect to that date. We import the data frame and as incremental COVID daily deaths, and let's take a look, and let's run, of course, this cell. Let's take a look at our COVID daily deaths info. We have date, region, deaths, people, and deaths per million. Perfect. In fact, if you can see here, incremental COVID daily deaths, let's take a look at detail. We have date, region, deaths, and you can see just by taking a look at the values, we are talking about the actual deaths reported with respect to this date, the 17th of December 2020, and this is the computation of the deaths per million with respect to that day. Now let's create the graph. I will be faster than before because we have already studied something of the properties of the Altair library. Again, we want to display a line plot, so we define the chart. We will refer to the incremental COVID daily deaths, and we will use mark line, and finally encode something, this something, and then we have line. Okay, here what do we want to do? Something similar with respect to this. For example, the x-axis will be the same, so let's copy. Also, I will copy almost everything here about the encoding arguments. So date is still valid, that's per million, we will see in a moment. This is not, these are not cumulative daily deaths, but are the actual daily deaths per million people. We refer to the region, that's the same as before. The opacity, let's comment a little bit just for now, because we have not yet defined the selection. And the size, it's fine. Let's use a size of 3. As you can see here, we have a problem in our data because we don't know why and how, but for Trentino Alto Adige, the daily deaths for this specific date are actually negative. Quite strange. Probably the original data imported was corrupted, must be fixed. In fact, in the GitHub repository of from which I was able to get the data, there are several issues about opened issues about some mistakes in the computation and the data in general. But to fix this problem here in the data, let's just hide. We care the negative values. We care only about values from 0 to 100, 110. So here we modify the alt-y object, specifying another property, the scale property, which is a scale object, of course, and takes domain equal from 0 to 110, and clamp equal to true. So it cuts the graph in order to, you can see here, from 0 to 110. Next we have, let's consider this selection here. Well, let's copy this because we will use the same properties. Okay, amazing. This is a mess, and again we have to define the selection, which will be the same as before. So this selection will be a multi selection with respect to the field regions, binds to the legend. We unlock the opacity again. We make the opacity very small here, and also we will add the selection to our chart. Let's rerun the cell. Now, for example, since we have an alt value that small, all the lines are almost non-visible. The way we selected the lines is the same as before. We press Shift and then we click on the region we want to display here. Okay, finally we will deal with the historical monthly deaths comparison. Here I import the data frame. Let's take a look at what we have inside this data frame. In particular, we have the month, the year, of course, the death type, COVID, non-COVID, or total, the region, and finally the deaths per million. now what we want to represent is a bar plot. So in order to create a bar plot, we define this bar plot as bar. We store the plot in a bar variable, which will be defined as an alt chart. What we will represent here? Well, we can create a bar plot referring only to one region. So first of all, we have to create a mask which refers to only one of the regions. So East region would be equal to region, and region would be, for example, Lombardia. Second thing, well, we will see then. So we have East, okay, which will be selected using this mask. We want to create a bar plot, so we tell mark bar. We'll define some properties here for our bar plot, some nice properties, and finally we have encode. Let's forget about the properties about the mark bar, and let's begin with the encode. First, x, what we want, which will be our x variable. Of course, will be defined as this. Alt x will be the month. Month. It's an ordered categorical variable, and we don't want any title of our axis. Title equal to none. Another thing that we will do will be Alt Y. Of course, will be that's per million, quantitative variable, and we want to specify a custom axis title for our axis. So axis title will be monthly deaths per million people. Okay. So right now what we have here, we are considering the month and the deaths per million. Okay, that's fine. But there are another we discard this variable because we have created the filter using this mask. Okay, so let's forget about the region. We have problems with the year that changes and the date type. First of all, we want to create a stacked stacked bar plot, in which the first part of the bar will be the non-COVID deaths, and the upper bar will be the COVID deaths. So we have to discard the rows that have a death type equal to total. So here we mask 2 will be historical, that's monthly, that's death type not equal to total, and we add this mask here, mask 2. Okay, now we have only the rows with that type equal to COVID and non-COVID. That's fine. So we can create a filter using the color argument, the color property of the graph, which of course will be a color object that will refer to the depth type, which is an unordered variable, categorical variable. And for now we will define only the legend title by typing legend is equal to alt legend title equal to depth type. Let's run. Okay, there's something, let me maybe this is creating a problem. Yes. Okay. Okay, so the axes are stacked together, and you can see here that we have the non-COVID and the COVID. That's what I would like to do is to reverse the colors. I prefer the normal bars to be light blue and the COVID deaths as orange. To do this, we will define a domain and a range. The domain will be non-COVID and COVID, and the range will be two colors. Will actually refer to our custom palette. This is equal to the light blue, and this refers to the color orange. These are the same. So we have to specify the domain and the range in the alt color object. We can do this by referring to the scale property, which is alt scale, refer to domain is equal to domain, and range is equal to range underscore. Much better. Let's increase the font size, add the title and so on. I just copy paste from my notes here. So for example, here I'm configuring the axis, the legend, the title. I'm adding this title and increasing the width and the height of the chart. Here it is. I personally don't like these bars, so I would prefer to round them, since I can do this. Since Altair allows me to do these things. So, for example, calling the corner radius top left is equal to 3, and the corner radius top right equal to 3. We are just rounding a little bit the corners, and also I would like to add an opacity equal to alt value 0.5. Excuse me, this 0.5. Okay. Maybe it's too much. Okay. Another thing that we have to add here is the interactive part made by selection. So let's create a selection here. That will be the same as before, so I just copy paste. Okay, I add a selection. And the selection. And finally, I add the usual opacity specifications. Oopsie. Opacity is equal to alt condition selection alt value 1001. Let's call it. For example, here I can click did I forget something? Selection here. Okay. Opacity. Oh, maybe there's a problem with this. Let me check. This should be all correct. Yes. Okay, now things work. Another thing that I want to add is are the tooltips. So if I position my mouse on this bar, I would like to the Altair to tell me the region, the depth type that I'm toggling, and the value of the deaths per million. So I add a tooltip equal to alt tooltip region, which is the variable for which I wanted the tooltip, and also I add a title region. I do the same for that types and that's per million. That type, title, that type, that's per million, that's per million. Okay, let's run. And then now, if I move the mouse here, for example, I can read that for region Lombardy, looking at the non-COVID deaths, in March we recorded almost 1,800 deaths per million people. Another thing that I would like to do is to add some lines that refer to the total historical deaths. So here I copy everything from before, but I have to add something. I have to change something. Let's say in this way. So here I will actually use two charts together. A bar chart as this one, but also a line chart referring to the historical deaths. The simplest way to deal with multiple charts in actually the same chart, the same layout, the same plot, is to create a base chart. So here I will create a base chart named base, which will be an alt chart that we will use the entire data and code. We will have X, Y, so X will be months. We also specify the label angle equal to 0, and here we have the monthly deaths per million people. This is in common for all the other charts. Another thing that I want to do is to filter the data by region. I can do this by applying the mask 1 to historical compared monthly deaths, or I can refer to the transform filter function method implemented in Altair. We will do this second approach here. So here we have transform filter equal to alt field equal predicate. The field will be a region, and the value for which that field will be filtered is equal to the specified region. Here things are actually can actually be confusing, because here we are generating a JSON with the entire data frame and then we filter. I agree that here things are not optimized. A better approach would be to add the mask right here. But I do this here just to show you that referring to other charts in which I have already specified a chart and the data used by that chart, I can still apply filters using the transform filter method. So here I can destroy this, and finally I can refer to the bar plot. So here I don't have anymore the chart, but I have the base. Also this selection should be moved here, because we will apply the selection to the legend, because it's bound to the legend, and only the bar plot will have the legend. So we are defined that this base chart will be a bar plot. We encode the remaining things here with the tooltip, the opacity, and so on, but also with here. For now we have to forget about this configurations. But if you remember before, the condition here was not only about the region but also about the depth type. That's why we can introduce another transform filter here, and we will use the field one of predicate, in which the field will be depth type, and one of equal to COVID or non-COVID. Finally, we add the selection. Let's this can be. Let's comment this thing for a minute, and let's rerun. As you can see, despite the width and the height and the title of the plot, we still have the same chart. Notice that here we have defined angle 0, and the numbers are now in a vertical position, because we have specified here label angle equal to 0, while here they were horizontally linked. Now let's add the line plot. So let's keep this commented. Line plot. We will call it line, and will be base.mark line. Excuse me. The color of the line will be black. We will type the encode, which will be simply by detail equal to here, which is an ordered categorical variable. Detail is the same as color. It does the same thing. It creates a sort, it divides the lines with respect to this to the values of this column. So we will have a column for the year 2020, one for 2019, and so on. We will just consider the total depth, so we can do this something like this: transform filter depth the type equal to what? To total. And finally, actually that's okay, and finally we can stack the bar plot and the line plot together using the alt layer. So the figure, the complete figure will be, so let's complete figure slash plot will be created by layering together the two charts, the bar chart and the line chart. We will configure the axis for the figure, we will configure the legend, the title, and the properties. Excuse me, this. Now we can run the figure. Here we are. So we have finally covered several ways on how to create interactive plots in using the Altair Python library. In the next course we will use this library to create a sort of prototype of a web app that will ingest data about the COVID deaths and will adjust the interactive plots with respect to that data. Creating this sort of web app will allow us to introduce what login is and what unit tests are. So stay tuned and see you in the next video. Bye.